Alright, so next lesson here, this one is independence of perpendicular vectors. This is where stuff starts to get a little bit confusing, so you might have to watch this video a few times or ask some questions in class. You can understand it, it's just going to be a little bit tricky, but you can do it. There's no problem. By no problem, I mean you might have to work to understand it, but I know that everyone can understand. I know. Now all of you are like, oh, he's saying it's hard, so it's going to be really hard and I can't do it. That's why I'm saying you can. If you automatically think it's hard, I can't do it, guess what? You're not going to do it. So I have this mindset that you can learn. You're more than capable. It's just going to take some effort. There's my motivational speech for today. All right, we're going to learn about perpendicular vectors today and how to solve some problems in 2D. Here we go. For example, we've got a boat trying to travel east across a 250-meter river. The boat can travel at a speed of 15 meters per second in still water, and the river flows at 9 meters per second south. We want to know, first of all, what is the boat's total, meaning resultant. Total is resultant. Those two can be interchanged. The total velocity if they point due east, meaning they go straight across instead of at an angle. So the distance here is 250 meters in that diagram there. The boat is pointing directly east, 15 meters per second. But if the river is flowing south, 9, the boat isn't actually going to travel straight across. It'll actually go at some diagonal. This is the total or the resultant velocity it's talking about. I need to add these two things. Notice the way I drew it, there's a triangle. So we're going to use some triangle equations in 2 dimensions. You've learned this before a long time ago. So you should have seen this. This shouldn't be a problem, but I will at least re-explain it as a recap. In this case, we need Pythagoras. We know the 15, we know the horizontal, we know the vertical. We just need hypotenuse. A squared plus b squared equals c squared. I just rearranged it with the variables that we have here. Plug in numbers, go ahead and solve. Don't forget to take the square root. And our total velocity, or resultant, is 17.5 meters per second. Now, velocity is a vector. Since it's a vector, I need to include direction as well. I cannot just give a number, I need to have direction. But this isn't a problem as well. I'm just going to use tangent. So tan is opposite, which is the velocity of the river, over adjacent, which is the velocity of the boat. Plug in numbers, south of east. Okay, so notice the boat, the 15-meter side is east. That's the east direction. And if I rotate south of east, that's where I get my total velocity. So again, going east, I rotated south to go south of east. Started at east, went south of east. So there is our total velocity. So now we want to know how long does it take to cross the river. So we have all the variables that we just solved for. We have the horizontal, the x component or the sideways component of the distance is 250 meters. And in order to solve the time, I want to use the velocity in the same direction. So v equals d over t. And we're going to specifically look at the x component or the horizontal component because the y component does not affect the x component. That's what it means if you have perpendicular vectors, x and y, are independent of each other. This just means what happens in y does not affect x, and what happens in x does not affect y. So solve these for time, we get 16.67 seconds. How far downriver does it go? So in the y direction, again, I'm going to rearrange this equation, and now we're solving for the y components. So we have the y velocity, we have the total time. We plug in those numbers, multiply them together, and you get your distance in the y direction that you traveled is 150 meters. Now, if it asks for displacement in the y direction, you'd have to put direction here, but it just says how far. That's a distance. So what I stated before, and it's important to know, perpendicular vectors are independent, meaning your x direction and your y direction, they don't affect each other. So what happens sideways, as the boat goes sideways, is not affected by what happens when the boat gets pushed down by the river. The speed at which the boat crosses does not affect the speed of the river. Like if I have a faster boat, the river is not going to speed up. Similarly, if the river is speeding up, that doesn't cause my boat to go sideways faster. It just causes it to go up and down faster. That's what it means by independent. You change one, the other one doesn't get affected. So to find our total or resultant vector, we do vector addition like I showed you, and we need to include direction. Don't forget that angle. And we are not using plus or minus for direction. We did that in one dimension kinematics. Positive and negative will not occur here. So let's do a similar example as the last one, except instead of them pointing straight across, east, now we want to know what angle should they point so that they will travel straight across the river. Meaning, last one, it was like they went like this, the river went like this, they had a resultant like here. Now this time we want to go straight across, so we need to angle upriver. So this is what we want. We want to go straight across. So in order to go straight across, I angle the boat up so that the river pushes it down and gives us this total horizontal velocity. So notice the total is not the hypotenuse in this case. Now it's the x component. So these two types of equations you need to be aware, both of them can happen. You need to read the question and be able to pick out what type of situation are you dealing with here. So we just need the angle for this, and this is pretty straightforward because we have two of the sides, we have the opposite and the hypotenuse. So with that, we can solve for the angle. And notice here again, the red line is east, and the angle rotates up north of east. Same example, except now we want to know how long will it take to cross the river. I have the distance in the x, but I need the velocity in the x. So first I need to figure out what is that total velocity in order to plug it in for time. So again, use Pythagoras, do some algebra, you get that your total velocity, or resultant, is 12 meters per second. Now we can plug this into the equation since we have both the x velocity and distance in the x. So that's how long it takes to cross. So there you go. There is some more tricky two-dimensional questions. We talked about reference frames and how that looks different. In this case, we talked about x and y components are different. Moving forward, we're going to talk about some objects falling, and it's going to be in two dimensions. Instead of just dropping something, it'll get thrown sideways. Alright, so this clip is actually a continuation of a clip I showed you last unit. If you remember the one with Superman saving Lois Lane as she falls down. This is the continuation of that, so take a look and see what else is wrong with this. Alright, so there you go. There is Superman saving everybody with catching a helicopter. So this one, yes, okay. So he's catching a helicopter. We're going to assume he's strong enough to be able to do that. That's not the issue here. The issue is something called torque. So torque is something where, if you're opening a door, closing a door, you are causing a rotation, is essentially what's happening. So in this clip, if we look at this, so Superman flies up, he's going to go catch this helicopter. Great, he's super strong, he can do that. But take a look at this shot right here. So Superman is holding this helicopter. He's holding it at full arm's length. Any of you have tried to hold anything of substantial weight at full length? That is, first of all, quite tough. And not only that, but he is holding this at full arm's length, and the majority of the weight is going to cause this rotation downwards. So he's gonna, his shoulder strength to lift up this heavy weight. Okay, we'll give him that. But the problem that's occurring here is not only does he need the strength to be able to lift up the helicopter, he now needs the forearm strength to be able to cause this to not rotate. And I will get you to try and do something like that. find a chair in your house or find something heavy in your house that is a little bit longer, and hold it out at arm's length and point it so that it's sideways, so that you have to try and keep it from rotating. That is really, really tough. He is holding this up, and look, there's no effort on his forearm here. He is not having to put any effort into causing this not to rotate around. So there's the problem with this one.